Good morning, everyone. Welcome back to the Real Electrical and Electronics Engineering series organized by the Faculty of Engineering, Multimedia University, Cyberjaya, in conjunction with the school holidays. For those of you who have joined us at 10 o'clock, welcome back. And for those of you who have just joined us, thank you for joining us. And stay tuned for a very interesting discussion today about 3D printing with Professor Fabian Kung. And also, please stay tuned for our other webinars, which has been organized throughout on the 8th, 9th, and 10th of June with other interesting topics such as autonomous vehicles and also renewable energy. So without further ado, let me introduce to you our speaker for today, Engineer Professor Fabian Kung from Multimedia University, Cyberjaya. Good morning, Prof.
Morning, Siva.
Thank you for joining us on our webinar series. And Prof. Fabian will be actually sharing his experience on 3D printing. Prof, maybe to start off, you can elaborate a little bit about the concept of 3D printing itself.
Okay, so this three-dimensional 3D printing is what we call is a type of rapid prototyping technology. So rapid prototyping means if you have a design or a concept, you can quickly come out with create a structure or prototype. In engineering, we call it prototype of the design. So you can do it rapidly within like a few hours to 1 day. So there are many rapid prototyping technology. Later, I have some slides which I can illustrate, and also some videos. So 3D printing is just one of it. Basically, it uses, typically the material is plastic. So it build up a solid object layer by layer by printing a layer on top of one layer on top of one layer. So by stacking this layer, so the layer are printed. Then we can create a solid object of almost arbitrary shapes. So it's a very quick way to create a solid object. Instead of like traditionally what you want to do with a solid object, you need to cut, you need to saw, you need to file, you need to carve, engrave, and so forth. So this you build it layer by layer using a machine.
Okay, so how long does it take for us to print out one
Okay,
3D design?
that will be interesting. It actually depends on the material you use and of course the size of the object, all right? Later, I will show you a video. For very small shape, it takes about 5 to 10 minutes. Small shape means something like 2 centimeter by 2 centimeter by 5 centimeter. Also, it depends on quality, how much material you want to use. But for big object, now you can print actually for a small tabletop machine. You can print a crash helmet, a motorcycle helmet. That will take 24 hours.
See,
So
and
you
is
need to
there
leave. Yeah.
a software that they use to design before we start the printing?
Yeah, we use a mechanical CAD computer. CAD means CAD. CAD. CAD stands for computer aided design. So we use a mechanical CAD software to draw out the design. Now this software can be, you can use a commercial software. You can also use, now we have open source and also free software.
And maybe you can elaborate to our viewers today, what is the advantage of this 3D printing?
So it's actually, yeah, now in the old days, like 20 years ago, you want to make something, then you need to go to professionals and very skilled worker. So today you can do it in your, say, in your studio, in your house, and maybe in your room. So it democratized the process of creating for everyone. So everybody can learn to make things. Yeah. So there is this, if you Google for this word, makers movement, makers, MAKER, you can see that globally there are hundreds of thousands of makers from different domains. So we in Malaysia also have a lot of makers.
Okay, and how about the challenges of doing this 3D printing?
Actually, it's very easy to learn. Now, some of you, some of your school actually got 3D printers. Yeah, I'm sure some of you have seen it in your school. Your what? There's a subject called Recapento and Technology, if I'm not mistaken, now in your curriculum for Sekolah Menengah. You will see this 3D printing introduced in your curriculum. So you can see even students as young as primary school students can do this 3D printing.
So why then do we need skilled labor to do 3D printing? For example, why should somebody learn engineering to do a very good
Okay,
3D design?
so now the difficult thing on 3D printing is not so much on the printing process. It's like using your electrical. It's the designing process. So in order to print, you need to be able to draw the mechanical structures. And if so, whatever the machine print out is what you draw or design. If you don't draw it properly or you design incorrectly, like you need to know about mechanical strength of material and certain structure. You need to reinforce certain portion, uh, or you need to make the design such that it's narrower so that it become flexible. So all these things you need to learn out. Printing itself is very easy. Everybody can do it. And then later I will show 3D printer is very cheap nowadays. It's about the price of your mid-range smartphone. So it's not expensive than your smartphone. Thus the process of drawing it is not easy.
So you are when you say mechanical structures, you mean that we can actually make huge structures using a 3D printer,
Yes,
like a house,
industrial.
maybe?
Yes, uh, industrial scale, industrial machine, and industrial 3D printing machine can print out the components of your car. They can print out metal, so you can print out gears and the chassis of the car. If you Google now, they also can use 3D printing to print out the parts of the rockets stages.
Wow, very interesting. So the reliability of the product that is 3D printed is exactly the same as when it's manufactured in
Okay, about
factory.
10 years ago, so we talk about plastic material, printing plastic. uh, in 10 years ago, the strength or of the material print, the structure printed with 3D printing is about 30% of injection molded. But today we should be able to get close to 50 or 60% of the strength. So it's not as strong as like you melt the metal and then you use a cast or you melt the plastic, use a mold to do it. Because later you see we make the structure layer by layer, so between layer you can the mechanical adhesion is not as strong as really melt the material.
Okay, so there are some challenges in 3D printing, but I'm sure that uh, the engineers and scientists and researchers are at this stage doing research to increase the durability and the strength of the 3D printed materials and all that.
Yes. So another 10 years or 20 years in future, I guess we should be able to get 3D printed component as strong as injection molded. Now you envision in future, let's say your machine damaged and you want to buy a spare part. Instead of buying a spare part, you download the design and then you print it out at your home or maybe a shop nearby, and then you can customize and things like that.
I see. That's interesting, Prof. Maybe I would like to see the video that you have. Maybe it's a good time for you to show
Okay,
it to us.
maybe I start with Siva. Is okay if I start with showing some of the slides. I just have about five or
Sure.
six slides.
Sure. Over to you.
Okay, so just let me share my screen. Just give me a few seconds to set this up. So, uh, so this slide is just to give you an idea what is 3D printing. Basically, this is a process to create a solid object. In this case, we are focusing on plastic, but you can also print metal nowadays. It's not difficult. So this 3D printing is an additive. So it is an important word. This is oops. This is an additive manufacturing process. So you add some. A solid object is created layer by layer by depositing molten plastic from a hot nozzle. So you have some machine that you melt the plastic and then you eject the plastic out from a nozzle. Now, suppose you want to create this solid cylindrical shape object on the right hand side. You can see my cursor. So in 3D printing, what we do is we print it layer by layer. We build this structure layer by layer now, like this. So you make layer number one, then you make layer number two, layer number three, four, and so forth until you create the structures like this. Each of this layer is roughly, so let me just draw on this. So you, and there is some, so you build it from certain thickness of the layers. Typically nowadays we can do it from 0.5, 0.05 millimeter to something like 3 millimeters. So it depends on your setting. Of course, you make the resolution, that means the thickness small, then you will take longer to make the structures. If your shape is irregular, so then you can adjust. So the machine can actually adjust the shape so you can print arbitrary shape. So I use cylinder to simplify the explanations. Uh, Now, so just now I talked about additive. So there are basically two ways to make a solid object. Another way is called subtractive. I have a video, actually this is from YouTube, so it should be, it's under Creative Commons license. So you can Google for this term subtractive manufacturing process and you can see hundreds of videos. So subtractive is instead of adding, so here you add a material to build a structure. Subtractive is you remove the unwanted material. So an example of how you do it is carving, you carve out, engraving, and another term is called milling. Milling is you use something like the rotating tools to cut off the unwanted material. This is shown on the video on the right. I'm going to play this video. It might show some lags on your side, but hopefully you can just get the ideas. So, so this is actually taken from YouTube. You can see you're cutting out a metal, piece of solid metal. So this is called milling. Right? Okay, so let me pause it. You see this word CNC in the title of the video. It stands for computer numerical control. So all these are computer numerical control by computer. You can do by hand, but of course it's not accurate. So this is a very common process. Most of your mechanical parts, like your mechanical parts of your automobile, your car, are actually manufactured in this manner. CNC machining using milling. Okay, let me just, okay. So now come back to additive manufacturing process. So in additive manufacturing process, we actually have two main methods. One is called fuse deposition modeling. The second method is called stereolithography. Okay, so these two methods are used in 3D printing. That means, just let me highlight this 3D printing process. So 3D printing actually can be split into FDM and SLA, stereolithographic. In FDM, basically the raw material comes in the solid filament. The raw material is a filament. Hot nozzle melt the filament and then deposit on the molten material layer by layer to build up a solid. In SLA stereolithography, the raw material is in liquid, like a liquid polymer. Then we use a laser to solidify. Once you heat up the liquid, it will solidify into a solid. So again, you build it layer by layer by using a laser to heat the liquid polymer. This SLA is typically used for professional industrial usage. It's much more precise than the FDM, and it can create material very complicated shape. Just now I talked about strength, and I mentioned about 30 to 50% strength of the injection molded. That is applies to FDM. SLA can go much higher. Okay. So there are two major types. For our consumer and hobbies and amateur, normally we use FDM. So this is low cost and consumer. And the industrial typically we use SLA. I have two videos, so this is very popular, low running cost, and later I will show a video, our own video, okay, of how we go end to end process. Just a quick one. This one is just to show you the FDM where we use a filament. Again, just about 30 seconds video. So this is a standard desktop printing. So it uses, so you can see this deposit the material layer by layer using a filament. Okay. Now this one is the bottom video, lower right is SLA. Watch carefully. Formlab is quite a famous company making these 3D printers. You see the yellow color light, that is actually ultraviolet laser. Look carefully on the end products. You can see the shape is very complicated. Right? So there are two major types, FDM and SLA. Okay. Let me just proceed to the next. So finally, this is a standard desktop. It's a low-cost 3D printer. Uh, so this is actually a FDM type. So it's FDM. So it uses a filament. And you can see the filament over here. So this is the plastic filament. So it fits into a nozzle. There's a nozzle over here.
See, okay.
And this is the platform. So basically, this nozzle, it can move sideways, and it can move up and down. And the platform itself can also move. So you can see there are three axes, right? So there are three perpendicular, or in mathematics we call orthogonal axis. You can move back, front, left, right, up, and down. That's the reason why. So we have three axes, and that's the reason why we call it 3D printer. That's the name come from. Okay. So these three axes allow the nozzle to build a solid object layer by layer. Okay, so with that, I have created a video to show you the end-to-end process. Basically, I show you how I use a mechanical CAD to draw a shape and then print out the shape and then show you the end product. For this example, I'm making a boat. So this is a boat. Boat means screw. So in layman terms, we call it screw. So this is a boat. This is a 6 mm boat. So the diameter is 6 mm. This is what we call M6 boat. So instead of using a metal, I use a plastic filament to make this boat and then to show the process. Let me just stop my screen sharing. So I asked Encik Bohan to actually broadcast it from the server. Then it will be clearer. Okay, let me stop my screen sharing. Encik Bohan, maybe you play the video, then as you play, I will narrate. Okay, so you can see I'm using a 3D mechanical CAD to draw. It takes a while to draw, so I just show you the end product completed design. So once this, after drawing, you need to use a software to slice the 3D structure. Basically, to slice it into layer by layer so that the 3D printer machine can understand. What you see on the right hand side is the slicer. Right. So I slice it, and you see, I enlarge the. Then you can see the layer by how this is made layer by layer. Okay. The slicer actually slice the 3D structures. The yellow color is the layers. After this, I send this the build information into my 3D printer. This is the printer that I show you in the photo just now. So basically, we turn on the machine. With the design is stored in the SD card. So I insert the SD card, and then we select the file, and then we start printing. You start, right? It's just like using your electrical appliances. So initially, when you start, you need to home the machine. Home means you go into a set location so it knows the machine know where the nozzle head is. And then you go, so you need to go through. You start to expel some old filaments. So that's what it's doing now. Now I play at 1x on the original speed. Later I will speed out the video. So the printing starts now. And you can see it's actually very noisy for this low cost. If you buy low cost means something like around 1,000 ringgit. More expensive like 2 to 5,000 ringgit. Then they have an enclosure. Then you will be it's has less noise. Now I speed up the process. 8 times the speed. So you can see the structure is being built up layer by layer. Okay, almost done. Okay, so this is done. So the end product is a screw, 6 millimeter screw. Takes about 9 minutes to print this out. And just try it out with a nut to make sure the nut can go in. Okay. Uh, More expensive. So this is a low cost. You can get something like a prosumer. Prosumer means professional consumer 3D printer. Then it will can print 2 or 3 times faster. So it depends on the software and the mechanical structures.
So would you say that using a 3D printer is more environmental friendly than actually manufacturing it in the factory?
Not really. Actually, you create a lot of plastic waste also. But luckily, most of the this some of the material for the plastic like polylactic acid (PLA), these are biodegradable. Most of the time we use PLA. There are other type like ABS, nylon, PPU, and so forth. Then they are not really biodegradable. You need to still recycle them.
So I think one of the programs that is offered by the Faculty of Engineering is the Bachelor of Electronics majoring in nanotechnology, right?
Yeah.
So do you think that uh, students aspiring to become nanotechnology engineers will actually help in this 3D printing future?
Mm, Now it's not so really related because of the scale, but this 3D printing is also applied to microscopic scale. Instead of printing plastic, you print molecule and atoms by atoms with what we call nano machines. And maybe you can build some synthetic cells and so forth in future.
And in terms of creating materials to be used in 3D printing, do you think the
Yep,
nanotechnologies will help?
that's is
Yeah.
that's a definite possibility.
Okay. And how about the other program that is offered by FOE, which is the Bachelor of Science in Intelligent Robotics? Is that related?
Okay, so of course, because of limited time, I can't show you a lot of stuff. But actually, myself as a roboticist, I use 3D printer to make a lot of robotic parts, customized because all these are our own design. I'm sure you can just Google around and you can see a lot of YouTube channels where they make a lot of fantastic robots and so forth. And all these parts are 3D printed.
I see.
So it's a very important skill for engineers, especially for robotics and automations.
Good. And the Bachelor of Science program that is offered by FOE, is it similar to a Bachelor of Engineering degree?
The Bachelor of Science and the Bachelor of Engineering, they are different fundamentally because the Bachelor of Engineering, they is, I would say, is qualified by Board of Engineer Malaysia. Bachelor of Science is, uh, so all degrees are qualified or accredited by MQA, Malaysia Qualification Accreditation. But engineering, you have another qualification layer by board of engineers. So if you are Bachelor of Science, you are actually technically you are not an engineer. You are a graduate of science degree.
But the program that is the Bachelor of Science is apparently more hands-on, right?
Yep. The difference is that the Bachelor of Science we emphasize more on hands-on, while in engineering, there I won't say we de-emphasize, but we place less emphasis on hands-on, but more on high-level theoretical understanding, so that like if you want to become a researcher, perhaps a bachelor of engineering would be a better path. If you are if you want to be a creator and want to do hands-on, then maybe a bachelor of science in intelligent robotic would be a better path.
And how long is it different duration to do the Bachelor
Okay.
of Degree and the Bachelor of Science?
So you need more theory. So engineering you need 4 years. Bachelor of science will be 3 years. That is not inclusive of the foundation, of course.
I see. But in terms of job scope, I would say that both the Bachelor degree and also the Bachelor of Science is going to provide a good career path in the next, say, 10, 20 years.
Yep. Yeah. But
And
actually, my advice is normally it's not so much on what you study, like it's the motivation and attitude of the candidates that determines their prospects.
maybe, Prof, you can also share with us what's your view on the current engineering demand globally. Is there a
Okay,
demand?
now is the most exciting time to live in because of the you can at your fingertip you can learn anything on your own. And then also now because we are at the verge of our civilization is on the verge of a breakthrough where we're going to we are almost on the verge of creating a machine that are like say truly adaptable and intelligent, and then we are almost on the verge of understanding many fundamental insights about say our nature universe, and we are almost at the border of being able to uh, maybe exist more harmony with nature and more sustainable. So there are a lot of demand globally for actually competent engineers. So I use the word competent, not half baked. So you need to be competent and good. And if you are competent and good, there are actually a lot of opportunity globally, not only in Malaysia, but anywhere in the world.
And what would your advice be to those students and our viewers today who are aspiring to be engineers, but they have certain hesitations about taking engineering as a career path?
Okay, engineering is not easy because of the fact that you need some foundation in mathematics, but it is one of the most exciting, not only engineering, but science in itself. It's very exciting. So if you are interested, I would say don't hesitate, and usually we start step by step. You can't imagine that 4 years you will become an expert and do something like an expert. It takes a lot of time and efforts. Personally, for my case, it takes me 10 years to become, I will consider a competent or expert engineer.
Yes, I agree. So, what we share with you in the university is your fundamental knowledge, and there is a lot of things that you actually learn by yourself and also on the job. And your experience and your exposure after you graduate, right, will determine to what level you actually become an expert in engineering.
Yeah, agree.
Okay, great. So, Prof, I think that's about my questions today. So, thank you for joining me and thank you for sharing your experiences with our online viewers. I'm sure they have obtained some insight on 3D printing. I mean, they probably already exposed to 3D printing, but I think sometimes listening from the expert, they get a bigger and wider perspective of what that whole technology is about. So, once again, thank you, Prof. Fabian from the Faculty of Engineering. And
Okay.
for the viewers online, thank you for joining us on the webinar series today. For those of you who have been with us since 11 o'clock, we will be flashing the QR code now for you to register for the webinar. Please stay tuned for our webinar series tomorrow starting at 10 a.m. Tomorrow we have two topics on energy, renewable energy, and also on the career path to become something known as an energy manager. So stay tuned with our colleagues, Dr. Xiao and also Dr. Ni, and we have two speakers from the industry, Prof. Kanan and Mr. Hanif from from Uniten, one of the sorry, Tenaga, one of the research wings of Tenaga, which will be sharing their insights with us. So thank you very much, and I wish you all the best and happy holidays. See you tomorrow.